Hello everyone, welcome back to my channel. This is part 5 of the series tutorial. So today we're going to start defining a wind load. So for wind load, you need only 3 steps. The first thing that you need to get is the original wind speed. Secondly, you need to get the side wind speed. And finally, convert the side wind speed into wind pressure. So the original wind speed is the region in which the country you're living or the structure is going to be built. And then the side wind speed is the particular side in which the structure is going to be built. It may be in the east, in the north, in the south, or it may be near to the sea and uphill on the mountain or in the forest. But that's the side wind speed. And finally, convert the side wind speed into wind pressure. So to get the original wind speed, which is step 1, go to the code, section 2 of AS 117.0.2. It says side wind speed is equals to VR times MD times MZ times MS MD. So all this is the factor, and VR is the original wind speed. So VR is the original wind speed in meters per second for annual probability of accidents 1 over R. MD is the original directional multiplier. MZ is the terrain heights. MS is shielding multiplier. MT is the topographic multiplier. So here it says go to section 3 to find VR. So open the same manual, go to section 3. It says the original wind speeds. Go to the table 3.1. You can see here it says region for non-cyclonic and cyclonic. And then the original wind speed in meters per second. We have V1 up to V100,000. So in this table, I'm going to ignore all this non-cyclonic region. I'm going for cyclonic region, which is C, because I'm living in a region where we are experiencing a lot of cyclones. So if you go down, to scroll down to the note, it says values for V1 have not been calculated by the formula for VR. For note number 2, it says for ultimate or stability limit states, refer to the building code of Australia AS 117.0 for information of values of annual probability of accidents appropriate to the design of the structure. So you see this value 1, 5, 10, 20, 25. These are the average recurrence interval, which states in this here in the note. Probability of accidents. Annual probability of accidents. They are found in this code. So let's go now, which is AS 117.0, table 3.3. It says annual probability of accidents. In this table we found it gives us the design working life, the importance level, annual probability of accidents for limit states, for ultimate limit states and serviceability limit states. So a design working life, it is the lifespan in which we are going to design the structure. So in this case, I'm going to design this structure, and I'm expecting this structure to survive more than 50 years. Consider if there's no any severe cyclone. So go back to my manual. I'm going to consider, for example, this 50 years. So I'm assuming that my structure will survive more than 50 years. So importance level, it is the importance that is associated with the type of structure. Let's say you are designing a farm. In that case, the structure is less important. So you might go for 1 because it's not associated with the risk in which people are going to use it. Let's say you are designing a residential house, say 2-story residential house. In that case, you might go for 2 because people are going to use it. So the risk in which is associated with this type of structure is also quite higher. Let's say you are designing a hospital or a 5-star hotel. In that case, you might go for importance level 3. So the higher the importance level is associated with the type of structure in which people are going to use it. So in my case, I'm going for this particular structure, people are going to use it for, on daily basis for selling, and then are going to accommodate people during a disaster. So I'm going for, let's say, 2, importance level 2, 50 years, and annual of probability of accidents. Ultimate limit state is 1 out of 500. What it means is, for every 500 round of cyclone, I'm going to expect only one cyclone is going to cause a permanent damage to the structure. That's what it means by 1 out of 500 annual probability of accidents for wind. There's no snow here, and I'm going to ignore the seismic effect because the structure is a shelter. Because the seismic load is something that is affected by the building mass, which is the floor mass and the wall. So there's no mass. I'm going to ignore all the masses here and the seismic effect. So I'm going to go for only wind loading. So 50 is importance level 2 and annual of probability, which is 1 out of 500. Annual of probability of accidents for susceptibility limit states is, if I go to the right, it gives me 1 out of 25. So I'm going to note all these values down, which I put all this value already in the Word document. If you go here, inverse annual probability of wind accidents R is equals to 25, and then inverse of annual probability of wind ultimate limit states, which is R is equals to 500. Remember, the word is inverse annual of probability. Here it gives you only annual probability. So the inverse annual probability is 500 because the table gives you 1 out of 500. So the inverse of 1 out of 500 is 500. And the inverse of 1 out of 25 is 25. It gives me here. Bring them down here. So the return wind speed, factor of susceptibility limit states 1.0, factor of ultimate limit states is 1.05. So which I've written the clause 3.4. So go to the code. Put the code. I think somewhere here. Factors for region C and D. For R greater than 50 years, Ft is equals to 1.05, which is for ultimate limit states, and 1.0 for susceptibility limit states. So if I go up to this formula, back to this table, regional wind speed in meters per second, because I'm going to design a building that is greater than, building lifespan that is greater than 5 years, which is VR is greater than 5 years, and I'm going to go for cyclonic region C. I'm going to use this formula. This is the formula that is used to calculate the regional wind speed. Regional wind speed, remember, regional wind speed here, regional wind speed. So I'm going to use this formula, FC, which is, I've already found the value, which is here 1.05 for ultimate limit states and 1.0 for susceptibility limit states. Got it. So 1.05 times 122 minus 104 times R, that is the occurrence probability, which is in this case I have 525. So 525. Go back. So regional wind speed for susceptibility and regional wind speed for ultimates. So FC times 122 minus 104 times 25 to the power of negative 0.1. So go to this code, you'll see to the power of negative 0.1. And finally we got the regional wind speed, which is given in the here which is 47 meters per second. That's for serviceability limit states, and for regional wind speed for ultimate limit states is 69 meters per second. Remember, that's the regional wind speed. We have not found the side wind speed. In order for us to find the side wind speed, we have to implement and compare the all the other factor, which is the ms and then mz cut mt, because all these factors are associated with the different sites that are going to implement and build the structure. So go back to the formula. We have already found our VR. Then the next thing is to get our MT, MZ cut, and MS. So my MD would be 1, which is the shielding multiplier. Go to section 3, go to my section 3, this is my MD. Okay, MD for wind direction multiplier for region C and D. Remember, I'm considering region C and D for 0.95 if I'm considering resultant forces and overturning moment. So there's no overturning moment at the base of the structure because the structure is a shelter. I'm going to consider for 1 for all the other cases. So MD is equals to 1. What else do we have? Terrain category 3. Okay, terrain category 3. Let me go back and explain here. Okay, so if you go up section 4, you will see site exposure multiplier. So terrain category 1, expose open terrain with few or no obstruction and water surfaces, no. Terrain category 2 for water surfaces, open terrain, grassland with few, no. I'm going for terrain category 3 with numerous closely spaced obstruction, because this building is located in the middle of the community, far from the sea, so there is no open water surface. So I'm going for terrain category 3, which is I've noted down here. And my MS and MT will be 1 and MZ cut, and Z value will be 6.8. Z value is the average height of the structure. If you go back to the code, scroll down, you will see the Z value. The Z value is the average height of the structure. So average height is to take the height of the eave and the height of the apex, and then we get the average. So the average here is 6.18. You take this value plus 5.6 and then divide these two values by 2. Then we get the average. And what else do we have? MZ cut. MZ cut is the interpolated value that we've got from our Z value. So if you go to this table, you will see, go up a little bit, MZ, yeah, here. We've got already our Z. Our Z is 6.18, which is between 10 and 5. Terrain category, I'm going to terrain category 3 for region C and D only, because here is A, W and B, so I'm going to ignore this table. I'm going to use this table only, table 4.1b. The interpolated value between 5 and 10 for terrain category 3, which is between 0.8 and 0.89. So do the interpolation and finally I'll get the value as 0.83. And shielding multiplier MS close 4.3 and topographic multiplier close 4.4. So these two values I will get the default value as 1. So combining all these values together, remember already what we got so far is we got our regional wind speed. As soon as we got this regional wind speed, we have to incorporate the side effects into our regional wind speed to get our side wind speed, which is all this MT, MS and MZ cut factor. And combining all these values together, we get our side wind speed for serviceability limit states, which is 39 meters per second, and side wind speed for ultimate limit states, which is 57 0.27 meters per second. Now, where we get the serviceability and the ultimate these two values at the same time, because when we go for the column deflection, we have to use this value. The column deflection, we have to apply the serviceability limit states. When we go for design for member size, then we have to apply ultimate limit states. So finally, we got original wind speed and set wind speed. So the next part of the tutorial, we're going to convert our set wind speed into wind pressure, in which we are going to get our CPE and CPI value and convert this set wind speed into wind pressure. So guys, thank you very much for watching. Stay tuned for my next tutorial. Thanks. Like, comment and share. See you in the next video.